Hi everyone. Welcome to What's New in Intesis Winter Edition. I am Oriol Carbó, Application Engineer in the Building Automation Division. And today I'll walk you through the key updates in this winter release, including the new KNX Secure Gateways, new integrations for NIBE heat pumps, and MQTT support in our 700 series Air. So, let's start with a quick overview of the KNX Secure, what it is, why it matters, and why it's becoming increasingly relevant for building automation projects. So, KNX Secure is a secured extension for KNX that adds encryption and authentication to communications between devices. It was approved by the KNX Technical Board in early 2019, and the main idea is simple. Only trusted devices can send or receive KNX data, and messages can't be read or altered by unauthorized actors, devices, and other things. With KNX Data Secure specifically, each individual group telegram can be encrypted. That means that communication between sensors and actuators is protected end-to-end. And it works both on TP, twisted pair, and also RF for wireless installations. So now that we set the context, let's move to our new HVAC interface supporting KNX Data Secure, and I'll show you what products we are releasing and what makes them special. So here we are introducing the first Intesis Gateway certified KNX Data Secure for Mitsubishi Electric HVAC integration. There are two different order codes, but the same hardware. One for Mitsubishi Electric air conditioning and another for Ecodan air-to-water heat pumps. Both gateways bring KNX Data Secure, meaning encrypted and authenticated KNX communication, ensuring that only trusted devices can exchange data. This is especially relevant today, with European cybersecurity regulations becoming a real requirement in building automation projects. And in case of Ecodan, these systems are key for energy-efficient buildings, so secure and reliable connection is essential. And the important point, we add security without losing functionality, full control and monitoring through KNX, now in a secure way. And next, I'll go deeper into the hardware and specific features of each model. So let's take a quick look at the hardware behind these new KNX Secure Gateways. This is a new generation device with a new enclosure designed to make installation easier and to fit directly inside AC unit thanks to its ultra-compact size, as you can see. From a commissioning point of view, configuration is done directly in the ATS using the product database, so the workflow is exactly what KNX integrators are already familiar with. And the gateway is KNX Data Secure, certified, as I said before, which means secure communication is built in a protocol level, not added as an external layer. So it's also designed to be ready for European cybersecurity regulations, so it fits both current and future compliance requirements, which is pretty important. Despite being a new platform, it remains fully compatible with CN 105 connector, so it works with a full Mitsubishi Electric HVAC range equipped with this connector. Overall, this hardware combines compact design, standard ETS configuration, KNX Secure certification, and full Mitsubishi Electric compatibility. So, these gateways are designed to cover both Mitsubishi Electric air conditioning systems and Ecodan air-to-water heat pumps using a common platform, and they are set up entirely through ETS following the standard KNX workflow, so there is no learning curve for the KNX integrators. So a key point is that the same approach applies across multiple Mitsubishi Electric ranges, including domestic, Mr. Slim, City Multi, Losnay, and also Ecodan. So the main idea here is consistency and simplicity. So we have a unified KNX Secure Gateway concept for Mitsubishi Electric HVAC, reducing complexity in project design and commissioning. Let's see now the key functionalities available in the KNX Secure AC gateways for Mitsubishi Electric. From a functional point of view, the gateway helps reduce energy consumption while maintaining user comfort by using features such as digital inputs, open window detection, occupancy control, sleep mode, and KNX scenes. The gateway supports up to 10 KNX scenes, which can be saved and triggered directly from the KNX system. It also allows preventive maintenance to be scheduled using the running hours counter, giving better visibility of system usage. And this is pretty important because the integration with KNX thermostat is smooth, allowing the AC unit to be controlled directly by the thermostat's temperature sensor, for example, also a touch screen, etc. Another important point is flexibility in control. The AC unit can be controlled simultaneously from KNX and from the local remote controller. And also, the remote controller can be blocked if required. On certain buildings, this can be really useful. The gateway includes 4 potential free binary inputs, allowing easy integration of external devices such as window contacts, presence detectors, pulse counter meters, or other digital signals. So now it's time for the EcoDAM model. It supports simultaneously control via KNX and the EcoDAM controller, and you can block the controller if required. It also exposes EcoDAM-specific signals such as error codes, leak detection, compressor, and pump monitoring. Domestic hot water status, including anti-Legionella, holiday mode, and total energy consumption. Maintenance can be scheduled based on operating hours, and energy consumption can be reduced by limiting set points for ambient temperature and domestic hot water. It also supports 2 climate zones. Also includes 4 dry contact binary inputs to be configured for dimming, switching, blinds, or energy measurement through pulse meters. Next, I'll show you a quick walkthrough of what the secure configuration looks like in ETS 6, the main steps from importing the database to setting up the secure group addresses. You'll see that it's really easy. So step 1 is importing the product database into your ETS project, just like you would do for any other KNX device. As soon as you add the KNX secure device to the project, ETS prompts you to set a project password. This is required to manage the secure commissioning workflow. Then ETS will prompt you to add the KNX secure device certificate. You can do this by scanning the QR code or entering the key manually. Each KNX secure device includes a certificate card or label with the QR code or an alphanumeric key. This certificate is used to authenticate and register the device in the network. And more important, each certificate is unique per device. And after that, you configure parameters. For example, you select the AC unit type, domestic, Mr. Slim, city multi-VRF, or ventilation like Losney, and also EcoDAM in case you've chosen this product database. Then you create group addresses and link communication objects, basically the standard KNX workflow that you already know. And security is automatically enabled for group addresses linked to secure the devices. Not every group address necessarily needs to have the security enabled, and you can adjust security later if it's needed. So it's about you to decide about that. And now I'll show you that in a live demo video to show the workflow end-to-end. This is a really short video showing this process described, just for you to see how fast it is to do it. So in ETS, we just add a gateway for Mitsubishi air conditioning. And once we add it, automatically appears this window. Here the camera scans the QR code for KNX Secure provided with our product and fills it for us. We click on OK, and that's it. Super easy. And now we select the product, and on the right side we can see that everything is in place. KNX Secure is enabled, and we also can see the serial number. And now if we select the room, we can see that our product has the symbol for KNX Secure enabled, and that's pretty much it. So that's it. As you can see, this is a really fast process and really easy for any KNX integrator. And I mean, we have a secure, really more secure layer on top, so I think it brings a really big value for any installation. So this was one topic, the two new gateways for Mitsubishi Electric, EcoDan and air conditioning with KNX Data Secure. Next topic, we are introducing a new protocol translator for NIBE heat pumps, supporting both KNX and BACnet in MSTP and IP variants. This is the protocol translator for NIBE heat pumps with KNX and BACnet. It includes dedicated NIBE templates and is configured using maps. The capacity is up to 5 units and 100 points, and a power supply is required. It combines wide NIBE heat pump compatibility with tools for energy monitoring and optimization. From the KNX perspective, the protocol translator exposes NIBE heat pump signals as standard KNX group objects using maps. This enables centralized heat pump control from KNX, saying modes, temperatures, set points, system status alarms, integrated with lighting, shading, and the rest. And the protocol translator continuously polls NIBE and updates KNX values for stable, predictable installations. And at the end, each signal supports arithmetic and logical operations, so you can match the points to the project requirements. And from BACnet side, NIBE is data exposed as a standardized BACnet object, so integration into BMS is straightforward without custom drivers. You get centralized monitoring and control directly from the BMS, plus advanced BACnet capabilities like trend logs and calendars for energy analysis. The certificates ensure a long-term stability and support, with the protocol translator designed for continuous operation in the professional environments, baked by Intesis HVAC integration experience. And here is the roadmap to set up these in maps. As again, you will see that this is really easy. First, of course, you have to download Intesis Maps configuration tool. After that, just select the protocol, KNX or BACnet, and configure it. Then select the specific NIBE template, and finally export signals and choose which ones you keep or remove. And now we are going to show another video.
So first we open Intesis Maps and select BACnet as the protocol. Then we can choose the template that has been created specifically for NIBE and we open it. Once the project is open, we go to Configuration and access the NIBE section. And here we select the device and click on Add from Template. Here we click on Download and we will be able to see all the templates available for NIBE. We select the required template, we load it, and the signals are automatically here. Then we click on Apply, and we can see that the device has already been created. Finally, in the signal section, we can check that all the signals have been loaded correctly. And that's it, fast and easy.
So let's move to our last product launch that we have for this winter window. I think it's a pretty interesting product, and well, it's really new for us. And it's the MQTT support for our 700 series Air, which has native MQTT as a standalone protocol. So I'll walk you through this, and I will also explain a little bit what MQTT is, and let's start with it. I would like also to remember you that you can throw your questions during all the presentation, and we will be answering them. So first, a quick overview on what MQTT is. And well, MQTT is designed to be a lightweight, meaning it uses very light bandwidth, and which makes it ideal for constrained environments or devices with limited connectivity. It's also reliable thanks to the different quality of service levels it supports. And another important aspect is scalability. MQTT can handle very large deployments with thousands of devices connected simultaneously. And finally, MQTT also includes built-in security mechanisms, such as TLS, SSL encryption, and authentication to maintain data integrity and privacy. So, MQTT is event-driven. Devices can publish data to the topics in a broker, and subscribed systems are notified immediately whenever there is an update. Here's the core model. The publisher sends data to a specific topic. The broker filters and routes messages to the right subscribers. And the subscriber receives data from the topics it follows. So the broker is essentially the traffic manager between producers and consumers of this data. One important detail, an MQTT client can act as both publisher and subscriber. Many devices publish telemetry and also subscribe to commands, and that's exactly what enables bidirectional control. And this slide shows a simple comparison of how integration looks today and how it looks with MQTT on the 700 series there. On the top side, we see the traditional setup using BACnet. The gateway integrates the HVAC system into a BMS through BACnet, which controls well in a classic building automation architectures. On the bottom side, we see the same 700 series air gateway using MQTT. Here the gateway connects directly to an MQTT broker using Ethernet without the need of a traditional BMS in between. And this approach fits very well with modern architectures, where data is consumed by cloud platforms, analytic tools, or multiple applications at the same time. So the key message of this slide is not replacement, but expansion. So the 700 series Air keeps supporting traditional protocols like BACnet, of course, and now adds MQTT as a new option for more scalable and IT-friendly integrations. This gives system integrators and customers the freedom to choose the architecture that best fits their project. So for the 700 Air series, MQTT is supported as a standalone protocol. Order codes remain the same, and capacity does not change. Existing installed gateways can enable MQTT via firmware update, which is pretty cool. So setup is done using maps, and MQTT communication uses the Ethernet port. So now let's talk about the key features. We support MQTT 3.1.1 and have broad AC compatibility and easy setup process. Also provide unified variable mapping to simplify multi-brand deployments. And security-wise is covered via TLS 1.2 and 1.3, plus remote certificate management for renewals. And the solution is tested with common brokers like Mosquito and Hive MQ, and cloud platforms like AWS and Azure. Finally, it supports bidirectional communication, so publish and subscribe, for full monitoring and control. This is a practical use case example using 700 series. The key takeaway to consider is that the Ethernet port is used here for MQTT communication in the setup. And about the configuration, the setup process is in maps. Basically, how you configure the gateway quickly and map data points for MQTT communication. As you can see in maps, there is the MQTT option, and there we can find different templates and choose the one we need. To better understand the whole configuration process, we'll see now a recorded video demo that will clarify it. On this case, we are going to use an example with AWS Broker. So let's go with it.
Okay, so now let's take a closer look at the configuration process. For this demonstration, we will use the AWS IoT platform from Amazon and specifically the MQTT test client. To connect to this platform, the gateway and any other device we want to use must be defined as an IoT thing, as well as have the corresponding device certificates, which can also be created during this same process. And if you need more information about this, please check the AWS IoT documentation. Now, moving on to maps, we are already connected to our gateway and have enabled an indoor unit, which is enough to see the signals we will be using. And signals can be divided into status signals ending with _S and command signals ending with _C. The information from the status signals is shared by the gateway by publishing to their corresponding topics, as we can see now in the publish section. Commands also use MQTT topics, but here the gateway acts as the receiver, so it listens to the command topic shown in the subscribe section and receives any commands published to them. For the MQTT client to send the command correctly, the payload must use the format shown here in the message payload section. Regarding the topic structure, it is important to note that there is a specific topic for each unit. So when using them, we must replace the indoor unit placeholder with the corresponding unit ID. The MQTT configuration begins at the connection section, and first we have to select the cloud platform. Currently we have AWS IoT Core, Azure IoT Hub, and a generic option for other platforms such as Mosquito. Now we'll select the AWS IoT Core, and next we must define a client ID which have to be unique. So for unique ID, we recommend using the gateway's MAC address, and can be entered automatically actually by pressing this button we have here, which is the MAC JW button. And for the host field, we must use the endpoint provided by the broker. In our case, we can find it in the connection details section of the MQTT test client. You may notice here that the version used by the MQTT test client is 5, but this causes no conflict with the version used by the gateway, which is 3.1.1, as AWS explicitly supports cross-version communication. The most usual ports are 1883 for regular connections and 8883 for secure connections. Usually we will use the latter as our connection to AWS is a secure one. However, for security reasons, IT departments may block these ports by default. If so, please ask your IT team to enable inbound and outbound traffic on these ports to ensure the system functions properly. As an alternative, AWS IoT also supports communication through port 443, which is used for HTTPS traffic and therefore unlikely to be blocked. In that case, we must define a TLS extension known as ALPN, short for Application Layer Protocol Negotiation. And this will be done in the security section after enabling SSL TLS. Keep in mind that ALPN is only required if the domain configuration has either the authentication type or the application protocol set to default. Back in the connection section, the remaining parameters can be left as is. You may notice though that the port number has automatically changed to 8883. This is because the port number changes automatically when SSL TLS is enabled, so you should keep that in mind when using other ports, such as the 443 port mentioned before. And moving on to the security section again, since we have already enabled SSL TLS, we just need to attach the corresponding certificate files. As mentioned in the AWS, these are downloaded when defining an IoT thing. And regarding the certificates, these include the 2 certificate authority files for the server authentication and the client certificate and private keys files for the client side. About the use of certificates, it is important to note that the gateway's internal time must be correct for them to be recognized as valid. A simple way to ensure this is by defining an NTP server in the general configuration section, so the gateway can keep its internal time up to date. Once this is done, we should be able to connect to the MQTT broker to publish statuses and subscribe to commands. So now let's save the project and send it to the gateway, and after reconnecting, we'll be able to test the connection at the diagnostic tab. So now as you can see, it's sending the project, and it's done. Once in the diagnostic tab, both the comms and the debug checkboxes at the MQTT viewer should be enabled to get the maximum amount of information. Our test will involve the ambient temperature status signal and the temperature setpoint command signal. We'll publish the first one so our test client receives it, and then the test client will publish a lower temperature setpoint value in response for the gateway to receive it. Since the ambient temperature is published by the gateway through the temp ambient STS topic, our test client must be subscribed to this same topic to receive the messages when published. To subscribe to this topic in the MQTT test client, copy the topic structure and paste it in the topic filter field. Remember to replace the unit placeholder with the corresponding unit ID from the unit. Having done that, press the subscribe button. And back to maps, we then enter an ambient temperature value in the diagnostic tab to force a publish to the related topic. For example, let's say 25 Celsius degrees. If everything's okay, the payload should appear in the test client description. According to the MQTT viewer, the payload has been received. So now let's check our test client. And indeed, here we can see that the payload with the published information have been successfully received. So after receiving this information, the BMS may want to set a lower temperature set point. The roles would then be reversed, with the test client publishing the message and the gateway being subscribed to it. So to publish the message from the MQTT test client, we need the topic and the payload. As a reference, both can be found in the message payload box from the subscribe section in Maps. Just enter the settemp.cmd topic name in the topic name field of the test client, and once again modifying the unit placeholder for the actual unit ID. Then enter the message payload, and as we have mentioned before, the payload format is predefined. So to avoid mistakes, we should also copy the payload from Maps and then set it to the desired value manually. We'll set it, for example, 21.5 Celsius degrees. After pressing the Publish button, let's go back to the Diagnostic tab in Maps to see if we have received information. And sure enough, as we can see, the temperature setpoint command has changed, showing the requested 21.5 Celsius degrees value. This value would then be applied to set a lower temperature setpoint for the unit specified in the topic. And that's it. I hope you liked the demo, that it was also useful for you, and now let's go back to the presentation.
So, as you can see, this has been a really productive video. I think that it explains very well how we can integrate with AWS in this case, but just understand that there are a lot of brokers that you can use, for example, Azure, also in the cloud. It will have a more or less similar process, but obviously with a different platform like Azure. But you can also do it in a really easy way, and I invite you to try it with Mosquito, which is a generic broker. So yeah, you'll see that it's really even easier than the process that we shown here. But we showed with AWS just to be able to show you how it is in a more complex, let's say, cloud platform like AWS, that you know it's really deep and complex in the whole system. And that's it. Till here the presentation of the new products for the winter edition. What we had for the webinar today, I just want to remember the new KNX secure gateways for Mitsubishi HVAC, the new integration with Nivea heat pumps, and finally this 700 series with MQTT. And for us, that's it. I really hope that you enjoyed the webinar. Sorry for these technical issues we had. These things happen, and I really appreciate that you have been here, and I hope that we can see you soon. Okay, thank you so much, and have a nice day.
Intesis, secured by design, trusted by default. Discover more at hms-networks.com/Intesis.